Hey guys, it's Willa Vaughn.
Hi, it's Anna Jones.
It is Chris Crow at your service, and we are the Mathematical Martians. Clever name, I know. So, we are going to be teaching you guys some algebraic reasoning. We're going to be connecting it to graphs, and we're going to be doing some minor geometry. So, without further ado, let's ask our first question. Miss Willa, I need your assistance. I need to understand how we're going to make these different graphs as they coincide with the different scenarios we're given. How do we figure out what graphs we need to make? How do we do that?
Okay, so first things first, your scenario. We've got a couple different scenarios. We have gas in a gas tank, flagpole shadow, bouncy ball, and elevator. So you take those and you kind of have to use a little bit common sense when doing it. So obviously here would be our gas tank one, and you have to label your x-axis and your y-axis, of course. And so you see it starts out kind of halfway full because it's at a stop in your distance on your x-axis. And then as it goes down in gallons, your distance is rising. So it's a very jagged kind of graph, and it's pretty self-explanatory in terms of the farther you go in distance, the less gallons of gas you would have. And so here, this would be our elevator one. It looks very much like a staircase. And you can see you go up in a floor and then you stop. And then you go up and you stop. You know, of course, just like an elevator would.
Okay.
And then here's our bouncy ball. And so it's very much like the gas tank one, and that as your distance goes higher, the height of the ball is going to go less because you're losing your momentum and the bounce to your ball. And then here is our flagpole shadow one. And so as the time of the day increases, so does the shadow of the flagpole. It'll go up and get higher.
Okay, so pretty much it's all somewhat self-explanatory, right? It's kind of directly proportional from one thing to the other.
Yeah, exactly. You just take your scenario and you kind of just imagine what you think your graph would look like, not necessarily exact points you would have, just a rough sketch,
Okay,
basically.
this is a very good explanation. Thank you, Willa.
Of course. So, Anna, I have a question for you. I'm wondering, on our function f of x, how do we get our g of x function from our f of x?
So our g of x function is basically the same thing as an f of x function. It's just a different way of saying it. And in this case, we have to find the g of f of x. So that is f of x inside of g of x. So f of x will go in place of the x in g of x. So in this case, we have what x equals for 0, 1, 2, and 3. We figured out for the f of x first, because it's easier that way. So for the first one, we have 3 times 0, because 0 is in place of x. For the second one, we have 3 times 1, which is 3. For the third one, we have 3 times 2, which is 6. And for the fourth one, we have 3 times 3, which is 9. And so we take those values and we put them inside of the g of f of x. So for the first one, we have f of x equaling 0. So it's going to be 0 plus 8. For the second one, we have f of x equaling 3. So we add that into the g of f of x. And so it'll be 3 plus 8, and that equals 11. For the third one, we have 6 plus 8 equals 14. The fourth one is 9 plus 8, which equals 17. And you see on our graph that we have the f of x line, and the g of f of x is perpendicular to that line because we're just adding 8.
All right, thank you so much, Anna.
That was a wonderful explanation.
Thank you.
Okay.
So, Chris, I have a question for you. What
Yes.
does y2 and x2 mean in the slope formula?
I'm glad you asked that, Anna. It's actually a lot simpler than most students might think. If they've never seen the slope formula before, it can be pretty intimidating because, letters in math, how do they work, right? So the x2 and the y2 and the x1 and the y1, those are simply the numbers in the ordered pairs. So in the pairs you see above, we have point P and we have point Q. And you can see they've already been mapped on the graph for us. The ordered pairs, we have 3, 1, and we have 5, 5. So within those pairs, we have our x and our y numbers. So in point P, we have 3, 1. 3 is going to be the x1, and 1 is going to be the y1 number, because those are the numbers represented on the graph. The 3 is on the x line, the 1 is on the y one, the y vertical, the y vertices. And the same thing with point Q. Both 5s are going to represent, this time the 5 will equal x2, and then the second 5 will equal y2. And the way the slope formula works is you have to take your y2 minus your y1, and then your x2 minus your x1. And you put them over each other. And once you do that, it's as simple as taking that final fraction number. So in this case, y2 minus y1, that's going to be 5 minus 1. And then x2 minus x1, that's going to be 5 minus 3. And then if you notice on the graph, the way the lines have been written and the triangle has been formed, we have 4 points going up vertically and then 2 points going horizontally. And so through the whole slope process, we come out to 4 over 2. And then obviously at that point, it's as simple as dividing 4 by 2, and then we get 2 as our final answer. So 2 equals m, our slope. And moving on to the second part of this, we have point P and Q once more. We have 5, 8, and then 5, negative 8. So we're going to follow the same formula we did before with slope. And if you notice, there's no triangle and there's no second line. And you'll see why in just a moment. So once again, we're going to do our numbers placed in their correct spots, and eventually that will come out to negative 16 over 0. And then that, obviously, anything divided by 0 is 0. So 0 means that it's just the one line. There's nothing else to add to it. It's a completely indefinite thing. And so we're going to move on to our third and final part of this question. We have points P and Q. We have negative 1, negative 4, negative 4, negative 13. And so the same thing. We're going to place these numbers in the y, or in the slope formula. So in this case, it'll be negative 13 subtracting negative 1. And something that you need to take note of, if there are two negative signs next to each other, they will combine to create a plus. So instead of negative 13 minus negative 1, it'll be negative 13 plus 1, just as a heads up for those who might get confused on the whole situation. But eventually, if you're doing it correctly, you will eventually come out to negative 9 over negative 3, and then once again, you're going to divide those numbers, which will then equal positive 3. So m equals 3. 3 is your slope.
All right, I'm thinking I'm starting to finally understand it. Thank you.
You are most welcome. Now, Miss Willa, I have another question for you because I am horribly ill-informed on the mathematical learnings.
Yes, sir.
How exactly do you go about finding the points in the graph to figure out these functions?
Okay, so you got to kind of have a starting point to find the points for it. So here's just a graph that's on here, and you can see the table. So say you've got the equation y equals x 2 squared. So you start with your table, and you start with just some random numbers, -10, -9, -5, and -4. You take those numbers that you just randomly got, and you put that in your x. So y equals -10 times the square root of 2 times 2 squared, you'd get 100. So that's how you get your points, because you're taking those randomly generated numbers and you're putting it in your equation to get the points. So like you would have 1. So you'd have y equals 1 times 2 squared. And obviously that's still just going to be 1 because it doesn't change. So that's how you get the points to your graph for just an equation.
Okay. And after you get all your points together, it's just picking the correct ones and creating the parabolas with it?
Yeah, you just like over here, you've got to make sure that your x and y, you're doing it the right way, finding it down here on your x and then going up and then plotting them correctly, and then you just kind of combine it and you get that nice little curve for your graph.
Okay, that was a really well put together graph and an explanation. Thank you very much once again, Willa.
Yes, sir. Happy to help. All right, so Anna, got one more question. I'm wondering, what does the x stand for in the equation of a line?
In the equation of a line. The x, give me a sec. Can you pause? Willa, can you pause?
Oh, yeah, sorry, couldn't hear you.
Technology, it's not reliable.
All right, thank you for asking that question, Willa. So for this equation, it actually comes with a y and an x that you don't actually attach a number to. So in this case, we're going to leave it alone, and it comes from the equation. All right, so here is a perpendicular line to our normal line. And you can see our normal line in this case is y equals -9 over 2x plus 5 over 2. And so to get our perpendicular line, we need to use the reciprocal slope of our original line. And the reciprocal is basically the opposite. So for -9 over 2, the opposite would be 2 over 9. All right. And then we're going to plug our points in to the x1 and y1 in y minus x1 equals m times x minus x1. So as you can see in the math over here, we have everything plugged in, and it comes out to equaling 2 over 9x plus 3. And as you can tell by our graph, it is perpendicular.
All right, well, thank you. I mean, that really helps me understand that a lot more.
That was
I hope
very well
so.
explained.
All right.
All right, Chris, I have a question for you now.
I have an answer.
What is the origin of a graph?
That's actually probably the simplest question, aside from the first one that we could have asked tonight. So the origin of a graph is the 0, 0 point on a coordinate grid. And what that is, that's the absolute middle. That's the absolute complete middle piece of any graph or any chart of the like. That's where the two lines meet in the exact middle. That is the origin of every other coordinate point after 0, 0. That's the origin. And it relates to our problem here because, as you can see, we have our graph set up, and we have the circle within the graph enclosed around the origin for the most part. And then we have our points 0, -9, -9, 0, 9, 0, and then 0, 9. And the radius of the circle, and the radius is from the origin to any halfway point from the circle. So that the little yellow box is around the origin. If we were to go any of these 4 directions, that would be the radius. And the radius, obviously, you can see is 9. And it's asking us to bring our square to point 0, -9 as part of the radius. And it's asking to explain the tangent of that line. And we will do exactly that. So the tangent of 0, -9 is 0, 9, because it's the exact opposite of the point we're currently given. And that'll be explained in this second graph here, where we see obviously the point we're going to go to is 0, 9, the exact opposite of 0, -9. And as you can see, the little yellow square leaves the origin point and goes upward instead of downward. And finally, comparing the 2 graphs, which we'll see in just a moment's time, every single one of these 4 points, so -9, 0 is going to be the tangent of 9, 0, because it's at the equal and opposite end of each other. And no matter which way you go, you could go horizontally, side to side, vertically up and down, even diagonally. If there were points that are available to us, they would all be tangents because they never meet of each other. And no matter what you do, the result of any one of these points is going to be y equals 9.
All right, very well
Wow.
put. Thank you.
Not a problem. And that concludes our Module 1, Lesson 8 presentation. I hope you guys learned a whole lot tonight. I know that me and my group members did. Thank you guys for listening with us, and I hope to see you again for our next lesson. This is the Mathematical Martians signing off. Once again, I'm Chris Crow.
I'm Willa Vaughn.
I'm Anna Jones.
And we will see you guys later. Stay fabulous.
Bye.
Bye.